Hi everyone. Today we're talking about something called the graph translation theorem, which you started to explore yesterday in your in-class activity. So these are sort of the more formal notes that go along with what you were doing yesterday. If you're struggling to finish that activity, I did post a short video that goes over kind of the second page of the activity, so questions 7 through 10. Probably be a good idea to get that done before you start these notes. The other thing I wanted to point out is I realized tonight when I went to open up this file that I may have included the wrong copy of these notes in your packet. It may be an older version. So towards the end of this lesson, if you're seeing that I'm doing examples that you don't have in your notes packet, just find some place to write them in, okay? Because you will want to definitely have them in front of you. And if there's things that I skip over that are in your packet, you can just cross them off. So sorry about that, and I might be totally wrong, but just if you're seeing things that don't line up with your packet, don't freak out, just copy them down someplace else. Okay, so thinking about what we did yesterday, our sort of base parabola, the one we were always comparing to, was y equals x squared. And the vertex of y equals x squared is 0, 0, right at the origin. Okay, so every parabola we talk about, every graph we talk about, is really just a translation of this parabola. This is sort of our kind of home base here. Okay, so when we look at this one, this was actually, I believe, well, maybe not. This may have been one of the exact ones from your activity yesterday. I don't remember. But what you should have found is that something like this minus 2 would have moved your parabola right 2. Okay, so that minus 2 in the parentheses would move you to the right. The plus 4 on the outside would move you up. So thinking about this on a coordinate plane, okay, if you were to go 2 to the right, so from 0, 0, 2 to the right, and 4 up, the coordinates there would be 2, 4. So the vertex of this parabola is 2, 4. Okay. We could also call that a translation, all right? And so this is all about translating. And if you remember from geometry, translating is just taking a parabola and sliding it. So if we start with this parabola and think of it as a translation, so we are literally sliding it 2 over and 4 up, we could call that a translation of 2, 4. Okay, notice that this translation, the coordinates down here in the translation, really just match the vertex. So when I write it like this, I'm telling you to make the vertex of your parabola be at those numbers. Okay, so then this one here, the y equals x plus 6 squared plus 3, a plus 6 would move you to the left. And again, this is all from observations that we made in our activity yesterday. And then this plus 3 would move you up. So if I was, again, starting on the coordinate plane, grab myself a different color here. If I was on the coordinate plane and I moved to the left 6 and up 3, the coordinates there would be negative 6, 3. So my vertex, negative 6, 3, and if I were to write that as a translation of this original y equals x squared, it would be a translation of negative 6, 3, which is really just saying move 6 to the left and 3 up. Okay? Now I want you to sort of notice the pattern here, that these numbers match these numbers exactly, except for one minor thing. This sign is always the opposite of what it really should be. So this is a minus here, but this 2 should be positive. This is a plus here, but the 6 is negative. Okay, so that opposite factor is going to be really important in this lesson, and one of the things I see the most mistakes with. Okay, so let's talk about what that's called. That's called vertex form, the way we write that equation. And the letters we use for the vertex always, and I don't know why, but this is the letters that have been chosen, are H and K. And you'll probably recognize those from the activity yesterday. I used H and K in a couple of the equations. So we write vertex form like this. Y minus K equals a, and we'll talk about what a stands for in a minute, x minus h squared. And remember, when you're writing equations like this, the y and the x really just stay y and x. H and k are going to represent your vertex, and then, like I said, a is, we're going to talk about later on. A controls how wide or skinny and what direction your parabola is pointing in. Now, the equations you were working with yesterday looked almost like this, okay? The difference was, instead of having y minus k, you had k over here. You had plus something over here on the other side. Well, the reason we did that yesterday, let me show you what this would look like. If I did plus k and plus k, it would look like this. Y equals a times x minus h squared plus k on the outside. The reason we wrote it like this yesterday is because our calculator will only function if we have y by itself. So the reason we moved k to the other side was to get y by itself. Typically we write our equations like this, but to put them in our calculator we need them like this. So that's sort of the advantage there. Now what I want you to notice is this formula, because that's really what this is a formula that you plug numbers into, has a minus sign in front of the h. So that minus sign is like built into the equation. And we talked about this a little bit when we did point slope form with linear equations. So if I'm plugging in a positive 5 for h, that's going to look like a minus 5, okay? Because the minus is already there and you're putting a 5 in that spot. If I was plugging in a negative 5, I would have minus a negative, and that would make it look like a plus. So that's where that opposite thing comes from that we were talking about a minute ago. That the vertex number is just this number, and this negative sign actually belongs to the equation. Now, the k has the same deal if you look up here. This is a minus k. So when it's written like this, the k is the opposite as well. But what we were doing yesterday, we moved the k to the other side, and then notice that the k is positive. So if the k is positive, then you don't have that opposite thing going on. If you put in a positive 5, it's going to say plus 5. If you put in a negative 5, it's going to say plus negative 5, or just minus 5. Okay, so if you move the k over, the k's are not going to be opposite, but the h's are. Okay, and that's what you were seeing yesterday. Okay, so for example, it says find the image of y equals 5x squared under this translation. So this is like a regular parabola. This one is going to be centered right at 0, 0. Okay, don't really need to know that to do the problem, but I just want you to have a concept. And then this is saying translate it this way, which is really wanting you to go negative 2/3 to the left. Okay, so 2/3 to the left, and then 6 up. Remember that when I give you these numbers, really what I'm giving you is the vertex, which is h and k. Okay, so that's all I'm really doing is plugging in the h and the k. So if I'm going to plug negative 2/3 in for h, that's going to go right here. So negative 2/3 is going right here for h. Now I already have a minus, and I have a minus here. So minus a negative 2/3 is really going to come out looking like a plus 2/3. Okay, and that's going with the x. Notice I put that in the parentheses with the x. My y value, or my k value, is 6. All right, that's going in right here for k. Whoops, didn't mean to put it by the minus sign, but so that number is going right in for k. And there's a minus sign in the equation, so it's going to stay a minus. So this will say y minus 6 equals 5 times x plus 2/3 squared. Notice that 5 is just your 5 from up here. So this is your a value. The number in front of x squared, that's what goes in place of a. Okay, here's another one. Same kind of thing. I'm still starting with y equals 5x squared, only this time I've got a different translation, but that translation, remember, is still just telling you what h and k are. So I'm plugging the 3 in for h and the negative 8 in for k. Okay, so if I plug the 3 in for h, there's a minus sign in the equation, so that's going to be a minus 3. If I plug the negative 8 in for k, I'll be doing minus negative 8, so that'll really be a plus 8. And then it filled the 5 in for me already, but the 5 just came from my original equation. Okay, so that's all you're doing is plugging numbers in. My third example wants me to find the vertex of this equation. Okay, and remember my vertex is always h and k. Okay, well here's my h number. Here's my k number. But really what you want to be careful of here, and I just figured that out, by the way, by kind of lining this up with the formula, which I have written up above here. The signs are what's going to mess you up here. When I want to say what h and k are, remember that this negative sign here, looking for my pointer, this negative sign here is part of the formula. So the number for h is just 7. But for k, if that's a plus 5, that's supposed to be a minus sign. So the only way we could have gotten it to be a plus is if that 5 had been negative when we plugged it in. So that's really a negative 5. This is like opposite day here. Okay? You've got negative 7 there, but that becomes regular 7. You've got positive 5 there, but that becomes negative 5 when you're pulling it back out of the equation. So the equation like disguises the numbers. It makes it look like the opposite of what it really is. Okay. Okay, a couple more things you need to know about these parabolas when you graph them. They can look two different ways, and I've shown you both of them here. This is what we would say, let's see, we would say that this one opens up, hopefully for obvious reasons, because the opening of the parabola is on top. This one we would say opens down. Okay, it's important to know the difference. And the way you can tell, I mean, obviously from a graph you can tell. If I give you a picture, you can look at it and tell me whether it opens up or down. But by looking at the equation, by looking at the numbers, you look at that a value. Whoa. So if you're looking at your equation and that a value, which is that number that's in front of x squared, if that a number is positive, you're going to have a parabola that opens upward. If your a value is negative, you're going to have a parabola that opens down. Okay, so a minute ago we did a couple of examples where it was like 5x squared. That would open up. Okay, if it was a negative 5x squared, that parabola would open down. By the way, the vertex of these parabolas are in two different places. You'll notice that when the parabola opens up, the vertex is at the bottom. So we would call that a minimum point. Okay, because it's a low point in the parabola. But when the parabola opens down, the vertex is actually the highest point. So we would say this has a maximum. So you're going to get questions where it's going to hand you an equation, and it's going to say, does this parabola have a minimum or a maximum? It has to have one or the other. It can't have both. Okay? To figure that out, first you have to figure out, does it open up or does it open down? And to figure that out, you're going to look at the a value. So the a value is either positive or negative. Okay? So when you look at that a value, if it's positive, you would say, okay, now I know that parabola opens up, so it must have a minimum. If it has a negative a value, you would say, okay, it opens down, so it must have a maximum. The other thing that that a value controls is how wide your parabola is. Okay, so down here under width of parabola, I want you to write this down. If the absolute value of a is bigger than 1, the parabola will be skinny. I should make that look like a 1. There we go. And what that really means, when I say the absolute value, I mean look at A. but ignore the fact that it's negative, if it's negative. Okay, so just look at the value of a, regardless of whether it's positive or negative. So if it was negative 2x squared, you would just be looking at the 2. Okay, if that absolute value of a, which again, absolute value really just means this. Okay, look at the a value without looking at whether it's positive or negative. If that absolute value of a is less than 1, 1 is always kind of your magic number, then it's going to be wide. Then you're going to have a wide parabola. Okay, because really, I know that's, again, kind of counterintuitive. You would think normally that if it's a bigger number, it's going to be wider. But this, if the a value is bigger than 1, if it's like a whole number like 5 or 6, that means it's growing 5 times as fast as a normal parabola heading upward. So if you're growing faster upward, the parabola is going to look skinnier. So you're going to have a parabola that's, teeny tiny like this one. Okay? If the parabola is less than 1, that means that's taking its time to grow, and so you're going to have a nice wide parabola like that one. Okay, that's a little bit dramatic, but you get the idea. So that a value controls, first of all, the sign on a. So the positive, negative controls up and down, and then the actual number controls whether it's wide or skinny. Okay, one more thing to throw at you here on this slide. Something called the axis of symmetry. And the axis of symmetry is a vertical line that runs right up and down the middle of the parabola. Okay. Now I want you to think about what you know about the equations of a vertical line, because you're going to be asked to write the equation for the axis of symmetry. The axis of symmetry is always just x equals some number, because that's how you write the equation of a vertical line. Think back to chapter 3. If I asked you, write me an equation for a line that would be vertical, you could say x equals 2, x equals 7, x equals some number will always be a vertical line. The question is, what number? Well, we know that this axis of symmetry goes right through the vertex, so it must have the same x value as the vertex. And you'll remember that the vertex is always h comma k, so the axis of symmetry is always just x equals whatever h happens to be. Okay, and we'll do an example like that in a minute. But axis of symmetry, one of the easiest questions I can ask you, especially if you've already found the vertex. If you know what the vertex is, just take the first number out of the vertex and write x equals that number. Okay, that's really all it is every single time. So don't stress out about that question. That's one of those questions people get wrong a lot because they think it's a lot more complicated than it really is. Okay, so whatever your h is from your vertex, just make your equation x equals that h number. Okay, a lot of information on this slide. Make sure you have it all copied down, and we'll practice it in just a minute. I think I have some examples in here. Okay. So the graph of y equals 4x squared is translated 2 to the left and 5 up. Okay, so if it's going 2 to the left and right is your h value, and left is negative on the coordinate plane, so my h value is negative 2. Excuse me. 5 up, that's your k value, so this would be k is equal to positive 5. Notice that I'm not doing the whole backwards thing. I'm not saying that, oh, it's moving to the left, but I'm going to make it a positive. When you're just looking at it as a translation, the numbers stay exactly what you would think they would be. So 2 to the left is a negative 2, 5 up is a positive 5. When I go to write my equation, I want to keep the formula in mind. So the formula says y minus k equals a times x minus h squared. Okay, so now I'm going to plug h in here, k in here, and then the other one I'm going to take is the a value. The a value comes from the original equation that I'm given. So for k I'm putting in 5, For h, I'm putting in -2, and for a, I'm putting in 4. Okay, take a minute and digest those. Make sure that makes sense. And then I'm just going to fill in the rest of my equation. So I have y minus k, so y minus 5, equals 4 parentheses. Now here I'm supposed to do x minus, but I already have a -2 there. So x minus -2 is going to end up looking like a plus 2 squared. And there's your equation. Y minus 5 equals 4 times x plus 2 squared. Okay. Next question. The point -1, 4 is a point on the pre-image. Find the corresponding point on the image. Well, what you're really saying to yourself here is I am taking this point, -1, 4, and moving 2 to the left and 5 up. Okay? So I'm going to take the -1 from this point. I'm taking this -1, and I'm going to add to it the h value, because the h value is moving me left and right. So I'm going to do -1 plus -2, and I get -3. And then I'm going to take the 4, which is my y value, and add my k value to it, because the k is the one that goes with the y. So 4 plus 5 equals 9. So my new coordinate would be -3, 9. I know that sounded really complicated, but all I did was take the original, or the point that it gave me, and I added the x and the y here to the h and the k from up above. So I took the x and the y and added them to h and k. H is always with x, k is always with y. And that gives you your new coordinates. And then C, there's that dreaded question. Write the equation for the axis of symmetry. Axis of symmetry is a vertical line, so it's always just x equals some number. And that number is always your h value. Okay, my h value from up above was -2. So my equation is just going to say x equals -2. That's it for axis of symmetry. Always comes from h. Okay, especially if you have h in front of you already, this should be a really easy question. Okay. So, in the figure at the right, the blue parabola is a translation of the dashed parabola y equals x squared. What translation maps the pre-image to the image? This is another one that people read and think it's a lot harder than it really is. You're writing this in translation form, which we did back on the original slide, where we wrote t and then at the bottom put the numbers that kind of showed where we went. Well, what this is really showing you is that this parabola shifted 3 to the left, which is a -3, and 2 up. Sorry, I just couldn't count for a minute. So 2 up, so that'd be a +2. That's it. That's your translation. You are saying, oh, I took that gray parabola and moved it 3 to the left and 2 up. Okay, there's your translation. Notice, though, that these numbers really just match the vertex of this new parabola. So even if I didn't give you the picture, if you know where that vertex is, you can write the translation. It's just t and then whatever the new vertex is. Now it says write an equation for that new parabola. Well, I know h is -3. I know k is 2. And I know my equation looks like this. Y minus k equals a times x minus h squared. So I'm going to plug those numbers in. Let's see. My -3 is going in for h. My 2 is going in for k. My a value, I'm looking back up here at my original parabola. It's telling me that my original parabola is just y equals x squared. My a value is what's in front of x squared, so it's really a 1. Okay, you actually don't need to write in the 1, but I will, just so you can see where I'm getting it from. And so then when I fill in the rest of this, I'm going to get y minus 2 equals 1. If I do x minus -3, that's really going to be an x plus 3 squared. So there's my equation. Y minus 2 equals x plus 3 squared. Okay, that's it. That was a pretty heavy lesson. There's quite a lot going on here. So you do have an assignment today. After you're done taking these notes, your assignment was Lesson Master 6.3a. Okay. I'm hoping you can get that done today so you're not taking it home over the long break. But that should be done when you walk into class on Monday. And everything you need for that, a lot of the examples that I did here in the notes came straight from that homework assignment. So please make sure you look back at these notes that you took, or even go back to the video here while you're working on the assignment if you're feeling stuck. Okay? Good luck.